In this question, we're being asked to factor these trinomials like we did in the last lesson. However, this time, the number in front of the x squared term isn't 1, right? If you remember all the ones that we did before, it didn't actually have anything out front. So this just gets a bit trickier. There's actually a few ways you can do this, but I'm going to show you guys the decomposition method. So I'm going to write this out again. So this would be 3x squared plus 14x plus 8. Okay, so first thing we want to do is we want to find some number that multiplies to the leading coefficient times the constant on the end. So I write it over on the side here, and I write, okay, I want to multiply, so I'll write like an m. I want to multiply to 3 times 8, so 24. All right, and then we still want to add to the middle number, just like we did in the last version. So I say a for add, and we want to add to 14. Okay, and then the negatives and positives do matter. In this case, everything's positive, so we want to multiply to positive 24. So I just started thinking of numbers that multiply to 24. So maybe you're thinking, 6 and 4. But is there any way to get from 6 and 4 to 14, right? If we were adding those? No, we can't add or subtract those to get to 14, so that can't be it. Well, maybe 8 and 3. But again, 8 and 3 aren't going to be able to add to 14, so that's not going to work. But what about 12 and 2? Right? 12 plus 2 is 14. So those are my numbers. Okay, so now this is different than the last one though. What do I do with these numbers? Well, what we're going to do is we're going to decompose. We're going to rewrite this 14 as the 12 and the 2. Okay, so this is what it looks like. We're going to just write this again. So we got 3x squared. And then instead of a 14, we're going to split that up as plus 12x plus 2x and then the plus 8 again. Okay, now it wouldn't have mattered if I wrote 2x plus 12x. It doesn't actually matter in the order of these things, but I did have to split that 14 up into those two things. That's why it's called the decomposition method. Okay, so now we are going to factor this thing by grouping. All right, what does that mean? Well, we're going to factor this thing by just factoring out this first part and then factoring out the next part, like just doing it on its own. So just bear with me, just follow along. So just looking at this first chunk here, we've got 3x squared plus 12x. So what's common there? Well, 3, what goes into 3 and 12? Well, 3 does, right? So the common factor there of 3. What's the common factor of x squared and x? Well, it's x. Okay, and then we're going to start a bracket, and then we're going to go back through and write what's left. So after I divided out that 3x, right, now what's left here would just be x. Okay? And then moving on to the 12, right? So 12 divided by the 3 we took out, that's 4. So I got to say plus 4. And now there's no more x, right? Because 12x divided by 3x, the x is canceled there. So now I'm going to end my bracket. Okay, so we did the first part. Now we're going to come over to the second one. And now we're going to factor the 2x and the 8. So what's common to 2x and 8? Well, just 2. But when we do that, we have to write, we're gonna factor out a positive 2. So it's like saying plus 2. And then start a bracket. And then what's left would be x, right, after that one. And then here we've got 8 divided by the 2 we took out. That's plus 4. Okay, so now here's one of the reasons why I like this method is because if you end up getting the same part in brackets there, you did it right? Like that's actually a really good sign that you're on the right track. Now we've done all the hard work. Now we just kind of have to recognize it when we see it. So what we're gonna do here, like I said, did you notice that we've got x plus 4 and x plus 4? So that's common to this chunk and into this chunk, right? It's common to both. So technically what we're gonna do is we're gonna factor out x plus 4. That's the thing we just took out. And what's left? Well, what's left is 3x plus 2. Okay, so that's really what happened. But if you want a quick, easy way to look back on that, notice that one of our factors was the one that showed up twice, and the other factor was what's left. And then that's it. That's how we factor those more complicated ones. So let's try the next one. So here I'm going to write it one more time. So we've got 12 y squared plus y plus 1. So sticking to our same method there, I'm going to find numbers that multiply to 12 times 1. So I'm going to write like an m up here and say, okay, the numbers I'm looking for need to multiply to 12. Okay. And then they need to add to, well, there's no number there, right? But there really is like a 1 sitting there. So they need to add to 1. All right, so I'm looking for numbers that multiply to 12 and add to 1. All right, so maybe you're thinking, well, okay, 3 and 4, right? Because they got a difference of 1 there. Like maybe that's the one. But that's not quite right either, because I need to multiply to positive 12, right? So that's only going to happen if they're both positive, or if they're both negative. That's not going to work out, right? 6 and 2 is never going to get me to 1. 12 and 1 isn't going to get me to 1. So this is actually a case where this actually just doesn't factor. So if it asks you to factor this, you just can't.